Hello team, we're back. Same integral, different, seemingly pointless, complex integration. Let's do it. We're still going to use ln e to the x, and if you haven't seen part 1 of this video, it's going to be available up there right now. Here we go. We're going to rewrite this as the integral of e to the ln x dx, which we're allowed to do because e and log of e would just cancel out. And then we're going to use a clever u substitution. We're going to say let u equals ln of x, the thing up here. Then I'm going to differentiate both sides. So du by dx equals 1 over x. And then I'm going to rearrange this for dx there. So I can do that by dx equals x du equals dx. And actually I want to get rid of this. So I'm going to use this, and I'm going to raise both of them to base e. So I'm actually going to say that e to the u is equal to x. U equals ln of x. The inverse of this, that e to the u equals x. So I can rewrite this as e to the u du equals dx. And then I've gone from an integration in x, where this is the same as this, to an integration in u, because I can rewrite this as the integral of e to the u du. And you might be thinking, oh, that's easy. I can just write this as e to the 2u, and I know how to integrate that. No. No easy calculus rules. Integration by parts. That's the only lesson I showed up to clearly, integration by parts. So we have this formula down here, which is for integration by parts, where we've got two functions multiplied together. And what I'm going to do, actually they're the same, so I'm just going to call this one u and this one v dash, so that it goes in my formula. And then I'm going to write that this is the same as uv, so that's e to the u, an integral of this, which is just e to the u, minus the integral of u dash, which is just this differentiated, which is shock, e to the u, and v, which is, oh look at that, it's also e to the u du. And now we have that the integral of e to the u in terms of u equals e to the u minus the integral of e to the u in terms of u. What might we do now? Well, we've got this guy, which is exactly the same as this guy. So what I can actually do is bring this over to the left-hand side of this equation. And so I actually get two lots of this. So two lots of the integral of e to the u du equals e to the u. So, straight up the integral of this equals a half e, and now we can do it, to the 2u plus c. How nice is that? And that's what we were looking for straight away. So I can actually just write that this is equal to a half e to 2u plus c. But I'm not finished yet, because what's u? Well, actually, I know e to the u is just x. So I can sub that back in here. This is the same as a half e to the u plus c, which is the same as a half of x squared plus c. So, obviously, the integration, well, not obviously at all, but the integration of x dx equals a half x squared plus c. Yes.